Hello everyone, welcome to Big Boy Physics. Today we'll be taking up a problem from the chapter of current electricity, and this question is based upon symmetry and superposition. I have taken this from a Russian Physics Olympiad archive. I got it from script. So let's read the problem. The problem says about little conducting cube. A little conducting cube is made of six identical conducting plates with holes drilled around their centers. Small identical cube conducting spheres are inserted into the cube vertex so that the wires can be connected to them. The hole diameters are such that the electrical resistance of the cube between two adjacent vertices AB turns out to be R is equals to 32 kilo ohms. If a current I is equals to 1 milliampere flows through the vertices in the direction as shown, a voltage across point M, that is the midpoint of HAB, and vertex C will be phi M, that is the voltage at M minus voltage at C, is equals to U is equals to 2 volts. Now you have to tell me the resistance AC between A and C. And second part says that how much will the resistance AB and AC change, RAB, RAC change, if the plate size and the hole diameter are doubled while the thickness remaining the same. Pause the video, spend few minutes solving this problem. I already gave the hint in the first that it involves a bit of symmetry and superposition. Okay, so let's get started. Well, they have given me some kind of a cube, right? It say that you have a cube and some holes are drilled at the midpoint of each of the plates and small spheres are inserted. Okay, so basically what will be the situation like that you have a sphere and sorry, you have a cube and spheres are inserted at the holes. Well, these spheres are of no use actually in this problem to solve. And it said that the resistance across AB is measured to be 32 kilo ohms. Now observe that a current I is equals to 1 milliampere flows through AB. Then can you tell me that what will be the voltage across A and B, that is VA minus VB will be simply RAB into I, which will come out to be 32 kilo ohms into 1 milliampere, which will be 32 volts. Now observe that if B is kept at 0 volts, then A will be at 32 volts. What will be the voltage at point M? Voltage at point M will be as it is in the midpoint, so it will be symmetric. The all the points I am indicating this plane, actually the whole plane will be at a constant potential, that is 16 volts, because it's the plane of symmetry. So M will have voltage equals to 16 volts. Okay. Now it say that Vm minus Vc is equals to 2. Can you tell me Vc? Vc equals to Vm minus 2, which will come out to 14 volts. Basically, point C will come out to be 14 volt. Now, if you remember, you might have solved a problem like the cube resistance. Cube resistance, in which you say that if this is my arrangement, and I assume that to find the voltage across these 2 points, then what we do is that we consider these to be the points of symmetry, and we just keep it to be V by 2 and here to be 0 and V. Now, if you consider to find the voltage across these 2 points, I am indicating by A and B. Now what we do that suppose here voltage is V and at point B voltage is 0. Then let the voltage at point C and D, point C be X. Then we say that voltage at point D to be V minus X. Similarly, if voltage at C is 14 volt, so voltage at D will be 32 minus 14, which will come out to be 18 volts. Okay. So basically we have indicated the voltage at each of the vertices. Hope you get it. So we have done till here. Next part comes that how can we find the resistance between A and C. We'll be just taking another such kind of cube. We'll be taking another such kind of cube in which the current is driven in through B and current is driven out through C. Okay. In this case, if it is 0 volt, now in this case I am assuming this C to be 0 volt, then what will be the voltage at B? It will be 32 volts. Voltage at A will be 18 volt, and voltage at D will be um, 14 volts. I'm not exactly completing by drawing all these spheres. Now superposing 30, what will be the voltage at point B? It will be 32 plus 0. So basically my figure will be something like this. Current is driven in through A, current is driven in through B, and as well as driven out through B. We are assuming 1 milliampere to be driven in and driven out in the second case, and 1 milliampere is driven out through C. Basically these two branches will cancel out, right? Now what will happen is that here voltage will be 18 plus 32, that will be 50 volts. Voltage at point A is 50 volt, voltage at point B is 32 volts, and can you tell me the voltage at point C will be 14 volts? Okay, hope you get it. Now can you tell me what is the difference between the voltages of A and point C? The VA minus VC is equals to 50 minus 14, which is equals to 36 volts, right? So RAC will be 36 volt upon 1 milliamperes, which will be equal to 36 kilovolts, sorry, kilo ohms. And that's the answer to the first part. Also, observe one thing. In this case, the plane of symmetry is this line, the line joining B and D, and the voltage at point B is basically the arithmetic mean of the voltage of point A and C. It will be true because it's a plane of symmetry. Hence, our all the suppositions were correct, and finally we'll get the answer of 36 kilo ohms as the voltage resistance across A and C. That is the opposite centers of the phase diagonal. So first part is done. Well, first part was a little tough. Then second part is easy because it said that these are conducting plates. If thickness is D and side is A, well, resistance is proportional to rho L by A. L is equals proportional to, you can write is approximately by only assuming the orders or the variables instead of considering the constants. You can write it as length is A because current will be flowing across the face. Okay, so length is you can assume it to be A, and what is the area? The cross section through which it will flow is A times D, and you can neglect this sphere because it will be a dimensional constant. If you, it's given in the question that we double the h as well as double the radius. Okay, we'll double the h as well as double the radius. As mentioned, you can read it here. Hole diameter is double and thickness is remaining same, and the plate size is also doubled. Basically, the edge length and the hole diameter both are doubled. Okay, so basically the dimensionally there won't be any problem of dealing with the resistance. Both will be equivalent, just similar diagram only be there, and you can see that resistance will be inversely proportional to 1 by d. So resistance is inversely proportional to thickness, hence thickness is remaining same, thus resistance will remain same. Second part answer is resistance is unchanged. Hope you understood this problem and enjoyed it. Thank you and have a nice day.